So hello everyone, welcome to the channel. So in this video we're going to show you monitoring Chlorophyll-a and vegetation indices for any study region using Sentinel-2A imagery in Google Earth Engine. So now let's get started. So the remote sensing technique using Earth Engine provides a powerful way to monitor the vegetation health and water quality at large scale. So the Sentinel-2A, a multispectral satellite mission from European Space Agency, offers a high resolution image with the multiple spectral bands suitable for vegetation analysis. The study leverages the various vegetation indices including NDVI, that is Normalized Difference Vegetation Index, and the Chlorophyll Index, Enhanced Vegetation Index, and Red Edge Chlorophyll Index to monitor the vegetation health and chlorophyll-A concentration over time. So this study uses Earth Engine to extract the vegetation indices from Sentinel-2A data and analyze the time series analysis from 2016 to 2024 and visualize the vegetation changes for the year 2018, and we're going to export for this particular year to our Google Drive. We're going to export this image of 2020 to our Google Drive. So I'm going to let me get back to Earth Engine. So to monitor the chlorophyll concentration in vegetation indices like NDVI, Enhanced Vegetation Index, and the Red Edge Chlorophyll Index, first we have to define our region of interest. So to define our region of interest, I'm going to define a variable called ROI, that is our region of interest, equals to earthengine.geometry.polygon. So below given, these are the latitude and longitude of the study region. So this is the latitude and longitude of this study region. So this is our study region. So to create a region of interest for any part of your world, so first we have to navigate to the location, and in that we're going to click this option called draw a rectangle. So I'm going to draw a rectangle over the region of interest. So once you did that, a new variable will be pop up here, variable geometry, and here I'm going to click this option called show generated code, and here I have my latitude and longitude of the study region. I'm going to copy this latitude and longitude of the study region, and I'm going to paste it here in this variable ROI. So once you did that, so we have our new study region. So this, using this particular set of latitude and longitude, it's going to convert this latitude and longitude into a polygon using earthengine.geometry.polygon. So now we have our region of interest. Let me turn this off. And next we have to center this layer. So to do that, we're going to define map.centerObject region of interest ROI with a suitable zoom level. So my suitable zoom level is 12. So you can arrange accordingly to your choice. So next, to add this layer, that is to add our study area layer, we're going to define map.addLayer region of interest color. I'm going to define red, and we're going to output the layer name as study area. And next we have to define the time range for our analysis. So for that, I'm going to define a variable start year equals to 2016 January 1, and the end year we define another variable to define the end year. For that, we're going to mention 2024 12/31, that is December 31. And next we're going to use Sentinel-2A imagery for our analysis. So we have to load our Sentinel-2A imagery into Earth Engine. So for that, we're going to define a variable s2 collection equals to earthengine.imageCollection Copernicus s2 sr harmonized. So let me explain about this particular dataset. So harmonized Sentinel-2 MSI multispectral instrument level 2A. So the dataset availability is from 2017 to 2025, and the dataset provider is European Union ESA Copernicus. And using this code, you can access this Sentinel-2A imagery S2 SR harmonized. SR represents the surface reflectance. So these are the following bands that is available in this Sentinel-2A imagery. So resolution of this particular dataset for B2, B3 and B4 is 10 meter resolution, and for B8, as it also has its 10 meter resolution, it is NIR, that is near infrared, and for red, green and blue also it is 10 meter resolution. Another band which has, for example, the B1, which has 60 meter of resolution, and B8 of A, that is Red Edge 4, has a resolution of 20 meters. So you can go through the details of other bands in this image, and the link will be given in the description for about the details of the harmonized Sentinel-2A MSI. So I'm gonna get back to Earth Engine. So next, once we access the Sentinel-2A imagery, next we're gonna filter with the specific timeline. So to do that, we're gonna define dot filter date start year and end year. So the start year is 2016 January 1 and the end year it is 2024 December 31. And make sure that I check for the dataset availability. For example, this particular image, the image availability is from 2017. So I have mentioned as 2016. I'm gonna adjust that to 2017. So in the filter date, to filter specific timeline, we're going to define dot filter date, start year and end year. And next, we're going to filter by our region of interest, that is our study region. So to do that, we're going to define dot filter bound ROI, that is our region of interest. So next, we have to remove the cloud contamination. So for that, we're going to apply another function, that is dot filter, earth engine dot filter less than cloud pixel percentage less than 20%. And in our next function, we're going to create a loop function. So in that, we're going to perform our vegetation indices, for example. So this is our normalized difference vegetation index. And we're going to perform chlorophyll index and enhanced vegetation index. And last, we're going to perform the red edge chlorophyll index. So first to do that, we have to create a loop function. So to do that, I'm going to create dot map function image. So image refers to our Sentinel-2A image. And in the loop function, we're going to create a variable called NDVI equals to image dot normalized difference B8 B4, that is normalized difference which represents B8 minus B4 divided by B8 plus B4, and we're going to rename as NDVI. So let me show you that. So the normalized difference vegetation index. So NDVI is widely used to assess the vegetation health and the density. It calculates the difference between the near infrared and the red band to indicate the vegetation. So for that, we can apply this particular formula, NDVI equals to NIR minus red divided by NIR plus red. So for Sentinel-2A band imagery, we're going to use this following band B8, which is NIR, and B4, which is red band. So we're going to get back to Earth Engine. So to perform NDVI, we use this formula, that is, we use this variable NDVI equals to image dot normalized difference B8 minus B4 divided by B8 plus B4, and we're going to rename as NDVI. So next, we're going to define another variable called CI, that is chlorophyll index. So to compute the chlorophyll index, we're going to use variable CI equals to image dot expression function, and in that we're going to define B5 divided by B4 minus 1. So here the B4, we're going to select this particular band. We're going to refer to the Sentinel image dot select B5, and B4, we're going to refer the image Sentinel-2A image, and in that we're going to select band B4. So let me explain about this particular CI, that is chlorophyll index. So the chlorophyll index is used to estimate the chlorophyll-A concentration, which is an indicator of plant health and photosynthetic activity. So to compute the chlorophyll index, so we're going to divide B5 divided by B4 minus 1. So it's going to give us the chlorophyll index. So these are the following bands will be used to in order to compute the chlorophyll index in Sentinel-2A imagery. That is B5, that is red edge 1, and B4, that is red band. So let me get back to Earth Engine. And now once we selected the band B5 and B4, so we're going to compute this particular expression B5 divided by B4 minus 1. So it's going to give us the chlorophyll index. So we're going to rename as chlorophyll index. And next we're going to perform the third index, that is enhanced vegetation index. So we're going to define a variable EVI equals to image dot expression. So we're going to apply this expression function. So 2.5 multiplying B8 minus B4 divided by B8 plus 6 multiplying B4 minus 7.5 multiplying B2 plus 1. So let me show you that. So enhanced vegetation index. So EVI is an advanced vegetation index that improves the vegetation monitoring by reducing the atmospheric and soil background noises. It is more sensitive in dense forest compared to NDVI. So the formula to compute the EVI is 2.5 multiplying NIR minus red divided by NIR plus 6 multiplying red minus 7.5 multiplying blue plus 1. So these are the following bands used to compute enhanced vegetation index in Sentinel-2A imagery. So B8, that is near infrared, B4, that is red, and B2 is the blue band. So this is a formula. So In order to compute this formula, we're going to define this function dot expression, and we apply this formula for the EVI, and in that we're going to mention the band B8 as our band 8 in Sentinel-2A imagery. So for that we're going to refer the image. In that we're going to select B8, and similarly for B4 I'm going to refer the image and I'm going to select band B4, and similarly B2 we're going to refer the Sentinel image and we're going to select B2. So once you did that, it's going to perform this expression, and it's going to give us the enhanced vegetation index, and we're going to rename as EVI. And our fourth indices, that is the Red Edge Chlorophyll Index. So to compute that, we're going to define a variable RECI equals to image dot expression B7 divided by B5, but subtracting minus 1. So it's going to give us the Red Edge Chlorophyll Index. So Red Edge Chlorophyll Index is useful for detecting vegetation stress and early disease symptom by using the red edge region of the spectrum. So formula to compute the Red Edge Chlorophyll Index is B7 divided by B5 minus 1. So to compute this particular indices in Sentinel-2A imagery, we're going to use B7, that is Red Edge 3, and B5, the Red Edge 1. So let me get back to Earth Engine. So to compute that formula, we defined variable RECI equals to image dot expression B7 divided by B5 minus 1, and we're going to relate the B7 in the formula. In the image we're going to select B7. So dot select function, I'm going to select B7. So B7, which represents the Red Edge 3, that is the B7 band of 20-meter resolution. And similarly the B5, I'm going to refer to the Sentinel image, and in that I'm going to select B5. So B5, which refers to this particular band, that is Red Edge 1 B5. So you can able to see this. And last we're going to rename as the Red Edge Chlorophyll Index, and we're going to return the image by using this particular function called add bands. So we're going to add following these indices as a band in our Sentinel-2A imagery. So for that we are using this particular function called add bands, referring to NDVI, CI, that is Chlorophyll Index, Enhanced Vegetation Index, Red Edge Chlorophyll Index. And we're going to copy this property to our image, dot copy properties image, system start time. And now we have managed to compute our vegetation indices. And next we're going to create the time series analysis to visualize the changes in the vegetation indices for this specific study region over the period of time from 2017 to 2024. So to do that, we're going to first create a time series analysis chart. So to do that, we're going to define print ui.chart.image.series, and in the image collection we're going to mention s2 collection dot select NDVI. So we're going to select the NDVI band in the s2 image collection. So we in the previously I have added, using add bands, we have added this following indices as a band to our Sentinel-2A imagery. So from that we're going to select this particular band NDVI, and the region, that is our study region, the red one here, this is our region of interest. And next we have to apply a statistical function in order to extract a mean NDVI value for each month. So for that we're going to define earthengine.reducer.mean function to calculate the mean NDVI value for the entire month. So for that we are applying this particular function .mean function to compute the mean NDVI value for each month. And the spatial resolution I have mentioned is 500 meters. So you can also reduce the resolution of this particular process, but in order to increase the speed of my computation, I have mentioned as 500 meters. So the resolution of this particular image is 10 meters. So you can also reduce to up to 100 meters. So in order to compute the speed of processing, so I have mentioned as 500 meters. And next X property, referring to the system's time start. And in the graph, we can mention this following set of things. So using this set options of function, so the title I'm going to mention as NDVI time series 2016, so 2017 to 2024. And the V axis I'm going to mention the title as NDVI, and the H axis I'm going to mention the year. And the color of this particular graph is the line is going to be in green. And similarly, in order to visualize the time series analysis for chlorophyll index for this study region over the period of time from 2017 to 2024. So we're going to mention the similar set of functions as discussed earlier. So print ui.chart.image.series, image collection s2 dot select. We're going to select chlorophyll index band in our Sentinel-2A image, and in the region I'm going to select the ROI, that is our region of interest. And in the reducer, we're going to define earthengine.reducer.mean function, and the spatial resolution is around 500 meters. And similar sets, we're going to set options to our graph, that is time series chart. So we're going to mention this title as Chlorophyll Index time series from 2017 to 2024. And on the v-axis, we're going to mention it as CI, that is Chlorophyll Index. And on the h-axis, I'm going to mention this year. And the color of the color line in the graph, I'm going to give it as blue color. And similarly, the time series analysis for the enhanced vegetation index. So similar functions. So we have to mention the statistical function here, that's the main function. And in the S2, we're going to select EVI band, that is enhanced vegetation index. And in the set options, I'm going to apply the title as EVI time series from 2017 to 2024. And the v-axis, the title is EVI, and h-axis, the title is year. And the color of this line is in red. And similar, the time series analysis for the Red Edge Chlorophyll Index. In Sentinel-2A image, we can select the RECI band, that is Red Edge Chlorophyll Index, and mention the region of interest, that is ROI. The statistical operation is main function. Scale is 500 meters. And the set options for this graph, we're going to mention the title as RECI time series from 2017 to 2024. In v-axis, we're going to give it as title as RECI, and h-axis is titles year, and the color code is purple. So now let us visualize the result here. So we're going to navigate this option called run script, and we're going to click run script. So now we're going to visualize the time series chart for each of this vegetation indices. So first we have our NDVI time series analysis from 2017 to 2024. So in this axis is NDVI, and this axis we have given year. So let us visualize this each of this time series chart for the vegetation indices. So let us start with NDVI for the study region. So the NDVI value has ranges from starting from 0.1 to 0.8. So the highest value is observed to be around this particular year, that is 0.774. So the NDVI value is around 0.77 in 2022, and the lowest value is observed in this year. So the value of NDVI is around 0.118, and during 2021 December 31st. So you can able to visualize here there is a drastic change in the NDVI value for this studied region. For example, this particular year has NDVI value is 0.7, and as it drops significantly and reaching to a value of 0.6 in 2019. And you can also visualize there is the lowest NDVI value is observed in this year in 0.154 in May 31, 2019, and similarly in this year December 31st, 2021, NDVI value reaching to a lowest value of around 0.118. And similarly, let us visualize other charts too. So the chlorophyll index, this is the time series chart for the chlorophyll index. So let us take a look at the chlorophyll index. So the chlorophyll values ranges from 0.2 to 2.0. So the lowest value is recorded in this year. So the chlorophyll index value of around 0.087 in 2021. And the highest value were observed in this year, so which is around 1.81 in 2022 June 24. So let us take the interpretation of the chlorophyll index. So higher CI value indicates more chlorophyll, indicating a healthy and actively growing vegetation, and the lower CI value, which shows us the chlorophyll value, the chlorophyll deficiency or stressed vegetation. So the higher CI value indicates the more chlorophyll, indicating healthy vegetation and actively growing vegetation. So the lower CI value indicating the chlorophyll deficiency or the stressed vegetation. So next, let us take a look at the enhanced vegetation index time series chart. So we're going to click this option here. So you can able to see here we have some extreme values which you can able to observe here. So the highest value is around 17.708. So you can also apply different statistical function. For example, instead of applying the earthengine.reducer.mean function, we can apply as the median function to avoid those extreme values. So we have seen here. So you can able to see we have this extreme values which can be observed here. So to avoid that, we can use the statistical function, that is dot median function. So let us visualize these values here. So lowest value was observed to be around so this particular value of minus 5.7, and the highest value for EVI values observed in this particular year 2023 May 17, around 17.708 EVI value. So interpretation for EVI value, the higher the EVI value, the higher the vegetation productivity. So if the EVI value is greater than 0.5, so which indicates the high vegetation productivity, and if the EVI value is lesser than 0.2, it indicates stressed or unhealthy vegetation. So for example, here you can able to see, so the value that is more than 5, which indicates healthy vegetation and give us more productivity, and if it is lesser than 0.2, it indicates the stressed vegetation. So let us visualize this last chart, that is our Red Edge Chlorophyll Index. So the highest value of this particular indices is around 2.475, so which is recorded in 2020, and the lowest value is around 0.138 in 2021. So you can able to visualize these extreme values. So to avoid, we can also use this already mentioned. I have that is in the statistical function we can use instead of mean we can use median function to avoid those extreme values. So the interpretation for Red Edge Chlorophyll Index, the higher Red Edge Chlorophyll Index indicates the high chlorophyll content and healthy vegetation, and lower Red Edge Chlorophyll Index indicates the possible vegetation stress or the disease. So now let us visualize this vegetation indices for 2020. So we're going to visualize this NDVI, Chlorophyll Index, and Enhanced Vegetation Index, and Red Edge Chlorophyll Index image for 2020. So to do that, first we're going to define this the variable called indices 2020 equals to S2 collection, that is Sentinel-2A image, and we're going to apply the filter function 2020 January 1, 2020 December 31st dot mean function in order to acquire mean image for this entire time period of 2020 January 1 to 2020 December 31st, and we're going to clip it based on a region of interest, that is ROI, and we're going to apply the visualization parameters. So for example, the variable NDVI vis, that is visualization, we're going to set a minimum of 0 and a maximum of 1, and the color palettes we're going to apply brown, yellow, and green for NDVI. So brown, which indicates the low NDVI value, and green, which indicates the high NDVI value. And similarly, we're going to define another variable. So CI vis, that is chlorophyll index visualization, we are setting a minimum of 0 and to a maximum of 1, and color palettes we're going to apply blue, which indicates the low chlorophyll values, and green, which indicates the high chlorophyll value. And similarly, we're going to define another variable, that is for enhanced vegetation index visualization, equals to set a minimum 0 and maximum 1, and color palettes red, orange, and yellow. Red, which indicates highest EVI value, lowest EVI value, and yellow, which indicates the highest EVI value. And last, we're going to define a variable for Red Edge Chlorophyll Index visualization, equals to minimum of 0, maximum of 1. Color palettes we're going to apply purple, pink, and white. The purple, which indicates the low Red Edge Chlorophyll Index, and the white, which indicates the highest Red Edge Chlorophyll Index. And to add this layer, we're going to define map.addLayer indices 2020.select NDVI. So we're going to select from this variable, we're going to select NDVI, and for visualization, we're going to refer this particular variable NDVI vis. So referring to this variable, and output the layer name as NDVI 2020. And similarly, to add a layer for chlorophyll index, we're going to use indices 2020. In that, we're going to select chlorophyll index band, and for visualization, we're going to refer to this variable here, and output the layer name as chlorophyll index 2020. And similar steps for other layers too. So we're going to select from this variable as EVI, enhanced vegetation index, and we're going to refer the visualization variable, so given here, and output the layer name as EVI 2020. Similarly for Red Edge Chlorophyll Index 2. And last, to export this the NDVI image, chlorophyll index, and enhanced vegetation and Red Edge Chlorophyll Index image of 2020 to a Google Drive, we're going to define this export.image.drive in image indices 2020.select NDVI. So from this variable, I'm going to select this particular image, that is this particular band NDVI, and description I'm going to give it as NDVI 2020, resolution. So you can reduce the resolution up to, I'm going to reduce the resolution to, so now I'm going to mention the resolution as 10 meters, and the region, the reservoir study region of interest, max pixel value 1:10 power 13, and the folder we can export is chlorophyll vegetation analysis, and the coordinate reference system is EPSG 4326. And similar set of process for other vegetation indices too. For example, chlorophyll index, we can apply the similar set of process, and also for the EVI, that is enhanced vegetation index, from this variable indices 2020. So let me show you that this is the indices 2020 variable. From here, from this variable, I'm going to select this particular band EVI dot select function EVI, and description EVI 2020. Spatial resolution is around 10 meters, and the region of interest, that is our ROI, and the folder and the coordinate reference system, and similarly for Red Edge Chlorophyll Index 2. So now let us visualize the result here. So you can able to visualize here. So I'm going to navigate to the layer section. First, let us visualize the NDVI image. So this is NDVI image of 2020 for this particular study region, and you can able to visualize here. So the highest NDVI values are indicated in green color, and the lowest NDVI value which are indicated in red color. So we're going to turn to a satellite mode here. Let me click this option, and you can now clearly able to visualize it. So all the red areas which indicates either the water bodies or the urban areas. For example, the yellow areas which indicates the, let me turn off this. So all the yellow areas you can able to see it is for urban areas, and all the red areas which indicates the water body of this study region. So green area which indicates the NDVI, that is vegetation areas. So you can able to see that. And similarly, to visualize the chlorophyll index, I'm going to turn on to this particular value, chlorophyll index 2020 layer. So now we are currently visualizing the chlorophyll index image. So similarly, all the blue region which indicates the lowest chlorophyll index value, and all the green areas which indicates the highest chlorophyll index value. So for example, let me turn off this layer. So you can able to see here all the urban areas and as well as the water bodies are clearly highlighted in blue color, which indicates the low chlorophyll values, and the highest level of chlorophyll values are indicated in green color. So you can able to see that. And similarly, we're going to visualize the enhanced vegetation index. So here you can able to see, so this particular indices is more suitable for the dense forest. For example, this study region is don't have any dense forest. So this index is more suitable for dense forest. So the red areas which indicates the low EVI value, and all the yellow areas which indicates the high EVI values. And last, we're gonna visualize this Red Edge Chlorophyll Index, and this particular index is very useful. For example, so the Red Edge Chlorophyll Index is useful for detecting vegetation stress and early disease symptom by using the red edge region of the spectrum. So the higher RECI value which indicates high chlorophyll content and healthy vegetation. If it is a low RECI value, the possible vegetation stress or disease. So here you can able to visualize here the highest values are given in white color and the lowest values are given in the purple color. You can able to see here. So the highest values are indicated in white color, and the lowest Red Edge Chlorophyll Index values are indicated in purple color, which clearly falls on urban areas as well as the water body. So you can able to view that. So all the purple areas which indicates the low chlorophyll, Red Edge Chlorophyll values. So for example, I'm gonna zoom to this particular area here. So you can able to see this is a urbanized settlement, so which is clearly highlighted in this particular image. So in purple color, which indicates the low chlorophyll values, and we're gonna navigate this part of the region. So it is to a settlement. So you can able to see here. So these are the farmlands. So here it indicates purple, which indicates the low chlorophyll values, that is Red Edge Chlorophyll values. And now let us take a look at the application part of this particular study. So now let us take a look at the application of the study. So agricultural monitoring. So the crop health assessment using NDVI and EVI, and detection of drought stress in the farmland, and yield estimation and precision agriculture application. And the second application is the forest monitoring. So tracking the deforestation and afforestation trend and assessing the plant stress due to the climate changes and monitoring the biodiversity and ecosystem stability. Next is our water quality monitoring, chlorophyll-a estimation in water bodies. So detecting the algal blooms in lakes and reservoir, assessing the eutrophication levels in water bodies, estimating the phytoplankton's concentration for aquatic ecosystem health, and the climate change studies, monitoring the urban green cover and vegetation loss, assessing the impact of temperature and precipitation on plant health, studying the global carbon sequestration through vegetation analysis. So these are the following applications for this particular study. So let me get back to Earth Engine. So in this video, I have shown you how to monitor the chlorophyll-a concentration and vegetation indices using Sentinel-2A imagery in Google Earth Engine. So link for this code will be given in the description. So thanks for watching, and make sure that you subscribe to our channel and give us a like.